Hi and welcome. This is a presentation on spatial analysis of non-riparian water use, diffuse determinations within the Fayetteville Shale Play of Arkansas. This fulfills the term project for GSEN 5383, fall of 2015. The class is Advanced Spatial Analysis and Design. Dr. Lucy Huang, PhD, Texas A&M Corpus Christi. And once again, if I haven't introduced myself, my name is Shawn Jackson. I work at Arkansas Natural Resources Commission. The Commission is a state agency which establishes policy and makes funding and regulatory decisions relative to soil conservation, nutrient management, water rights, dam safety, and water resources planning and development. The non-riparian water use program permits and monitors water use within the Commission. Arkansas water law follows the Riparian doctrine, which provides that a landowner who has water on their land has the rights to utilize the water. The state also recognizes the non-riparian water user, who may not have direct access to the water, but should have some water right to water use. The state water plan sets a percentage use for the non-riparian water user. Water use for hydraulic fracturing falls into the non-riparian water use program. A landowner having riparian rights to water sells the water rights to a representative of the hydraulic fracturing industry, and that representative or company is considered a non-riparian water user. Hydraulic fracturing for natural gas became an industry for the state of Arkansas in 2007. Prior to this time, the non-riparian water use program held 7 permits. The program now has processed approximately 1,759 applications. The applications are given a determination of active, diffuse use, denied, canceled, and withdrawn. For the purpose of this project, only the diffuse determinations will be used for spatial analysis. Diffuse use determinations are issued on applications when the location meets the following criteria. The source, which is a pond, does not fall in a delineated stream. The delineated stream is identified by both USGS topographic maps and the National Hydrography Dataset. The source or pond captures only overland flow. If the pond is fed by water, which occurs in an entrenched bed and provides inflow to the pond, or the pond provides outflow to an identified stream or identified identified earlier, the pond is considered to be a part of the stream and cannot be capturing overland flow. The best test for a diffuse determination is this: if the pond is removed, will the stream still exist? If the stream still exists, then a diffuse determination cannot be given. So the problem of this project is providing a diffuse use determination which exempts the water source from annual water compliance and is not tracked as water usage, since the source is presumably precipitation occurring as overland flow. This project is to utilize spatial analysis as a source to identify problem determinations and set standards for making a diffuse determination using spatial analysis. So what is the difference between a good determination and a bad determination, or a problematic diffuse use determination? On this slide, the X's indicate flow lines as identified in the NHD dataset. No ponds occur directly on top of the flow lines. The areas which have been circled have got diffuse use determinations. And you can see this is a topographic map with an aerial overlay. And the overlay, the transparency has been adjusted so that you can see through it and see the contour lines. The pond at the top clearly does not have any inflow or outflow. The pond to the south of the picture, or the bottom part of the picture, is it's difficult to see it, but you can tell that there's no inflow or outflow in this one either. The one at the top, the pond has existed since the time that the topographic maps were created. So these two points indicate diffuse use determinations, which I would consider proper determinations. This one would be considered is what I consider a problematic determination. You clearly have a flow line flowing through the middle of the pond. This should never be given a diffuse determination. So a little bit about the location. The Fayetteville Shale is located in the north central part of Arkansas. The data that's used for this project, I manage the non-riparian water use access database. Anytime you see NRWU associated with this project, that it refers to non-riparian water use. The database, I queried the database and exported the records to an Excel shape file or Excel file, then brought it into ArcGIS as a point file. The other data that I'm using is the National Hydrography data set, in particular the flow data and 12-digit hydrologic units. Then I'm utilizing an aerial-based map and hillshade-based map that is a online feature from the Arkansas GIS office. The NHD and the hydrologic 12-digit hydrologic units have been clipped to the project area, which was the slide before. And I tried to follow the process, this flow chart, which is in the ESRI help menu, just as general guidance on how to maneuver through the process. So this is my beginning map, and basically these are the three layers as I described earlier. The blue lines represent the flow lines. The purple polygons represent the 12-digit HUCs, and the green dots represent the 547 non-riparian determinations. So ultimately, the goal with this project is to identify problematic diffuse determinations using spatial analysis. And eventually develop a set of criteria which can be used in the office to determine what is a diffuse determination and what's not, as opposed to having to go out into the field and lay eyes on a pond. While gas is not very costly right now, it's time consuming to have to go out and lay eyes on a pond just to establish there's inflow and outflow, when I believe GIS is just as good of a tool. And the data that I'm using is, of course, it's not research data, it's application data, and The distribution on it is definitely, it's not going to be normal. And this just illustrates that fact, that there is not normal distribution within the data. Okay, a selection query provided a diffuse determination data set with a distance of less than 65 meters from the NHD stream segments. The point data, which is red in the map, and the stream data is the pink in the map. There are roughly 93 points that correspond to the stream segments. And from there, I moved on to utilizing the average nearest neighbor tool on that data, which resulted with the data set returning an index of 0.5, which indicates the data points trend toward clustering, and the z-score is a negative 21 with a significance of 0.01, which indicates that this is a 99% confidence that the data distribution is not due to random chance. And that's not surprising, again, with this data, simply because it's data that falls on water and on ponds. These results to me were not very surprising. And from this, I created a kind of a hotspot map, which highlights the HUCs with the most problematic determinations falling within them. And those are the red and the orange polygons. From there, I went ahead and created a kriging and the kriging co-kriging surface map, which surprisingly can be overlain with the problematic determinations. In this instance, I've utilized the kriging co-kriging map as contour lines, and it matches up very well to show the areas of which HUCs need to be focused on. So in conclusion, the problem identified in identifying problematic diffuse determinations within Fayetteville Shale Play in Arkansas can be solved using spatial analysis. The beginning data set included roughly 547 data points, which were narrowed down to 93 problematic diffuse determinations within 34 HUCs. The best standard derived from the study is if a pond with a diffuse determination falls within 65 meters or 213 feet of a stream segment, as illustrated in the NHD data set, then the determination should be to permit the source. In permitting the water source, the source is monitored and recorded annually, and by maintaining these standards, Arkansas Natural Resources Commission is being a good steward of the environment.